We are now going to learn how to create a custom Mask-RCNN detector to detect any object. For example, I picked screwdrivers, and this is the result I got. Hi, welcome to this new video. My name is Sergio and I help companies, students and freelancers to easy and efficiently build visual recognition projects. We're going to see today the easiest way possible to train a Mask-RCNN detector. If you're not familiar with this, let me give you an example. For example, we can pick an object. I have this screwdriver. If we train a detector to detect the screwdriver with Mask-RCNN, we will be able to detect the location of the object, doesn't matter where the object is, but also to draw specifically the polygon surrounding the object. So that's what Mask-RCNN does. And we're going to see the simplest way possible also online, so you don't even need a GPU or a powerful computer. We will do everything online using the free Google Colab Notebook. So if you're not familiar with this stuff, everything will be clear once we go on. And we're going to do this in 3 steps. On the first one, we're going to collect the images and prepare the dataset, and of course I will show you this. On the second, we are going to see how to train the custom detector with the Google Colab Notebook I've prepared and that you can download, of course, on the link below in the description. And finally, what you probably are most interested in is the first step, where you can take your model and use your model to detect in my case, the screwdrivers, but you can choose any object you want. So let's start right now. The first step that we have to do is prepare a dataset with the images. So in this case, for example, I have a dataset with a lot of screwdrivers, and you can do this with your phone. You can take pictures with your phone and they will be fine to go. So you don't need any specific things to take the pictures, as long as the object you're interested in is on the picture. So how do you need to take the images? Let's say, for example, in my case, I want to detect different screwdrivers. So I put a few screwdrivers on the table. I change the position all the time. So the more the variety, the better. And even if there is some other object, like in my hand or whatever, any other object, even if you're not interested in that one, is fine, because the model will consider that as a background after. So it's fine as long as you have your own objects that you want to detect right there. A few of them. And how many pictures should you take? Well, the concept is the more the better. So you could even take thousands of pictures, and it will be, of course, better than having few pictures, but it will take a lot of time for you later to make the annotation. So I will recommend to start with 50 images, 50 images, just to see how things are going, and then you can improve it later with more images. So in my case, for example, I have 43 images, and that's what I've got. Now, after the pictures, there is the annotation which we have to make. So the annotation, it means telling where each screwdriver is located on the image, so that later during the training we can teach the model to know the exact location. So we cannot just give the picture without anything else. We need to put the annotations. How do we put the annotations? There are many different softwares for this, but the easiest to use and the fastest that I found is this open source project, which is called makesense.ai. I will put the link somewhere on my tutorial. So you enter on makesense.ai, we click on get started, and now drop images or click here to select them. So what I'm going to make, I'm going to select all these images, and then I'm going to drop here the images. And we have now 43 images loaded. What do we want to do with these images? We want to make object detection, and this is where we need to click. Now we need to create a label. So before you start, you can create a list of labels you plan to assign to each object. By the way, this project is only for one label. So this is a demo version. We work only for one label. If you have multiple labels, at the end, I will tell you what you have to do. So I have also the pro version of this project that you can get on my website if you want more precision, more labels, and many other things. But for the moment, let's start with only one object. So if you're not sure what to make, you can just use my images. So you can download also for free the images. All the files will be available on my website on the link below. And let's go with this. So I have this object, and let's start the pro. Okay. Let's insert the label. I'm going to call this screwdriver. And I can now start the project. Here we will see all our images so that we can work with them. We have to make the annotations, but keep in mind, there are different types of annotation. One is the simple object detection annotation, where you just need to put a box on each object, like this. You're annotating the screwdriver, of course, maybe better than what I'm doing, more precise. So this is simple object detection, and that's not what we want to do. So I'm going to remove all these labels. Segmentation is something much more advanced than this. So it's not only a rectangle, but it's a polygon. So you can see on this right side of Make Sense AI that we can choose the type of annotation. So we have rectangle, point, line, and polygon. So we select polygon. And now we can start making the annotations. So with the mouse, I click here, and we need to select correctly our object. So we need to draw a polygon surrounding our objects. So like this one, this is the first one. And let's press OK once you have the polygon. Then we go on the second one. Like this. Of course, the better you make the polygon on this annotation, the better will work your model. So be careful to be really precise with these annotations. And it will take some time, so there is a lot of work. That's why I said start with a few images. If you're not sure, if you've never done this, start with a few images, and then later you can do the improvements. But at the beginning, there is already some work with this. I'm going to pause the video because I need to draw all the polygons. Once I have all the polygons, I will be back and we will go on the next step. So see you in a bit. After the annotation is completed, this is what you should have. So for all the images, you need to have all the objects with the polygon around the object. For all the images you have right here. So now we have the images and you have also the annotations. Remember, well, you need to do this. You need to download the annotation file. So after you finish, you go on Actions at the top left, and there is Export Annotations. And let's click here. You can choose two file formats to export the annotations. And it's necessary that you select single file in Coco JSON format. It's important that you use Coco format because all the steps after will support only this format. So it will not work with the previous one. Single file in JSON, Coco JSON format. Export. And then you need to select where you want to export this one. So I'm going to export this on screwdrivers. Okay, I have it already because I exported this before. You can call it, let's say, annotations. I suggest to use the same name I'm using because later it will be easier for you to follow. If you change names later, you need to change the names again on the next step. So just call this annotations.json. Okay, JSON is there already. Annotations, and then click on Save. I'm not going to do that because I have it already. Once you have images, so let's go back. So we have one folder with the images. Here are all the images. Plus you have the annotation JSON file. You're ready to move to the next step. So let's go on the training already. And right now we are already at the second step where we're going to make the training. For the training, I prepared a Google Colab Notebook that you can download. There will be a link where you click the link and you will get access to this specific page. If you're not familiar with Google Colab, is a notebook offered by Google that you can use online, and you just need a Gmail or Google account and you can log in here for free. Let me show you how to go further with this. First of all, once you are inside this notebook right here, this is the notebook, you need to enable the GPU, the graphic card, and this is important. We go on Edit, Notebook Settings, and then there is Hardware Accelerator. There is GPU, so none, GPU and CPU. By default, it's set to none. You need to enable the GPU. Why the GPU? Because we need the graphic card to make the training. There is no training without graphic card. And now we can start. So I divided this in 4 major steps, which I will show you. The first one is the installation. The second one is the image dataset that we need to load, the training, and then for the detection to test our model. Let's go with the installation. So there is not much that you have to do, honestly. So it's 4 steps, but you just press this one, you press start. This notebook was not authored by Google, so you need to run anyway, because Google is not granting that this notebook is from some external source, because I created this notebook, so you press run anyway. And now it will take a few seconds to complete the installation. So this is what you see right here. It's downloading some files and make the installations in order to be able to run Mask-RCNN. When you see this done downloading pre-trained model and here is not doing anything else, you can go to the next step. I've added this command, which is NVIDIA SMI, just to see if you have the graphic card enabled. Like, you don't really need to run this one. Here it's saying only that you have the graphic card enabled. So this is the name of the graphic card, Tesla K80, with 11 GB of RAM, but you don't really care about this. So you can run this one if you're curious to see the specs, what graphic card you're using, but you don't really need that. Also, if you run that, if you forgot to enable the graphic card, it will give you an error. So it's good that you run that. Step number 2, image dataset. So let's open this one. How does this work? You need to upload the images that you have on your computer, so the images that you created before, and also the annotation. So let's do that. First of all, where do we upload them? Right here on the left bar, there is a folder sign, and you click here, and it opens here all the folders that you have now on the memory. We should upload the files right there with these other files that you see there. So let's do that. Let's do that. I'm going to upload the annotations, so let's move annotations. Right here you see drop files to upload them on the session storage. And then we press OK. Here it's just saying that after the session is finished, all these files from the Colab will be deleted. So this is a temporary session, so that's what it is saying. Then dataset. Now there is something to do with dataset. As you see, dataset is a folder with a lot of images, as we can see right here. We cannot just upload straight a folder right there, but we need to make the entire folder into a file. So how can we do that? We can zip the folder on Windows. It's very simple. You can just click with the right button of the mouse on the folder and you go on send to, and then there is compress zip folder. And you will get dataset.zip with all the images right inside. So this is what we have. All the images. So what do? I'm going to put dataset right here with the other files. And now it will take some time to upload the files. So here you will see the progress bar. So when this circle is filled, the upload will be done. if you have a lot of images and if they are heavy, it will take some time, especially if you have a slow connection. I have only a small data set of 7 megabytes, so that's why it doesn't take that long. How to go further? Here we have on image dataset number 2, we have images path and then annotations path. Images path is the name of the zip file. So in my case, I have dataset.zip. I've just uploaded dataset.zip. So I need to put the same file name right here. So we'll say dataset.zip. Annotations path. So we have annotations.json, and it's the same in my case, annotations.json. Make sure that the path, the name is correct, and you press run on this cell. How can we make sure that everything was loaded correctly? Well, you will get a message where it says extracted 43 images. Of course, the number of your images have 43 images. If something is wrong, we will simply get an error, and so you will know that here you need to change something. Then there is the next cell that we need to run, where it loads the images on the memory. So, and you will see validation and classes, so one class, and now display images samples. So everything right here is regarding the dataset still. Okay, here it's this function right here is just loading random image to show that you have the correct annotation. You can see I have some image and then I have screwdrivers. Here is the mask done by the annotations. And you should see, of course, your own images right here with your own mask right here. And here it's normal that you see empty because this is done for multiple, in case you have multiple classes, but this demo version will work with only one class. So just use one object and not more than that. Once we're done with the images, it's the step of the training. So the training has two cells right here. The first one loads the configurations of the model. So we press run on this one. Now it's detecting for how many images are there, so the right configuration of this model. So everything, you don't see this, there is a lot of code written behind this, which is performing right now. And it takes just a few seconds, this one, a few seconds. And now after the configuration is loaded, we have the training step. And this is the step which will take the most of the time. So we press run. This is the step where the model is going to be trained to detect, in my case, the screwdriver, in your case, your class that you choose to train. So now the training hasn't started yet. When the training starts, we will see here epoch 1 out of 5. And we will see all the progresses step by step so that we also have an idea of how long this is going to take. Now around half hour is gone and we see that epoch 1 of 5 is completed with 500 out of 500 iterations. And it says here how long it took, 1421 seconds, so less than half hour to complete one epoch. So we can estimate that in total around 2 hours and a half it should complete the project. In your case, it might be taking less or longer because it depends on how big are the images that you have, but also on the graphic card that you are using from Google. Colab doesn't give you always the same graphic card. Sometimes it's faster, sometimes it's slower, so you can expect different timing for this. Now, I'm not going to wait that everything completes because at least one epoch is enough. So I'm going to pause this one. More than to pause, I'm going to completely stop this one. And I'm going to show you that we have the model just quickly. If we open the folder right here, Mask-RCNN that you see here, we have logs. object, this is our model. We have Mask-RCNN object 00, and then I don't see anything else. 001 is the first epoch H5. This is the model that later you can download. I will show this at the end of the project, so just I will leave this one there for the moment, and we will see that later, how to download the model so that you can import it and use it. While here at the end of the project, I have a detection, so this is just a code that you can use just to test your model without even downloading. So before downloading the model, you can test and see how this works. There are two steps right here. The first one is going to load the latest model created. So I have only one, so it's going to load that one. But if you have epoch 5 out of 5 completed, it's going to take like the latest one. So it's going to take the 5th one because it's likely that the newest one is the most precise one. And this is quite a fast operation. So we load this one, it will take a few seconds. You see loading waits from content Mask-RCNN logs Mask-RCNN object 001.h5. And now let's test this on a random image. You don't have to upload anything, the images are there already. It's going to just choose a random image from your dataset and see what is the result. So let's run and test this one. When you run the test, you will see two images, and I will explain how this works. This is the test, so it's working quite well already. It doesn't detect all of them, but the result is pretty impressive to be after only half hour of training. You see, it's the boundaries are maybe not perfect because it's like the screwdriver is not taking the entire screwdriver, so there is something missing, like this screwdriver is not taking it at all. But it's incredible that only in half hour we have such precision. And this is the annotation which is doing the comparison. So this is the annotation that was done. This is the image annotated, and this is how the model is working. So you can expect if you leave this training for longer, 2.5 hours, or like till completing the process, you can expect that it will get almost 100% of the things, at least in these simple settings. Let's load some other image. So I'm going to run this to see some other random image. It's the same one. Yeah, because I have a small data set, so it's only for okay, now we got a new image. So this is another example that I have. My validation dataset is only 4 images, so there is not a lot of choice right here. If you have at least 100 images or more, you of course you can test this with more of them. And this is how you make the training. So now, after only these simple operations, we have our model ready to run. Now, before concluding this, we will use another notebook where we load our model. So first of all, let's download our model. We go on Mask-RCNN, and then let me look for logs, object, and then there is a log number, okay, probably the date, 21, the date, and then there is 001H5. If you completed all the training, you will see 5 of them. You see 001, 002, 003. I suggest to just download the latest one that you have. So in that case, 005. So the highest number, you just click right here on the dots and then download. And it will take some time. So you see here the progress is 250, around 250 megabytes. The connection between the Colab and downloading is not fast in general. So even if you have a fast connection, it will take some time. So we need to wait that the download is completed, and I will be back with the next step to run our model. We're going to run now our custom Mask-RCNN detector. For this one, I have a second notebook that you can also download from the link. There are 2 links that I put on my blog post. One is for the training, and one is to run Mask-RCNN on images from Google Colab. And it is quite a simple notebook because it has only two cells. One is for the installation. This one is necessary ways to install the Mask-RCNN library. So first of all, we're going to run this one. And then before running the second, we need to upload our model. What is our model? Our model is simply our .h5 file that we've just downloaded at the end of the training. So you should have your h5 file on your computer, and we're going to upload that inside Colab. How do we do that? It is quite simple. We need to access the folders that are on Google Colab. We can access the folders right here. We can see now there is Mask-RCNN, which I have just installed. And now I'm going to upload my model. Right here I have a few models because I created a few models. You need to upload your h5 file. I have right here, which is called Mask-RCNN object 006, and I'm going to drop this file right here. It will say that once the runtime is finished, that once we close, we are going to lose the files, but that's, you should already know that from Colab. This is going to be a bit slow. The connection between Colab and the computer is always slow. So this 240 megabyte file, it might take even half hour to upload, even if you have a fast connection. This is why on the Pro version, I integrated Mask-RCNN, like the training and the detection with Google Drive, because with Google Drive, the connection is quite fast. So at the end of the training, all the files we will save on Google Drive on the Pro version. But for the moment, just for testing, this is just fine. You just wait half hour or the time it takes, and then we're going to load our model. So I'm going to wait that the file loads, and then we can move on. When the upload is finished, you should see Mask-RCNN object 00 and then the name of your object. I have 006.h5, so the h5 file must be here. And once we have this, we can go on the next cell, which is run Mask-RCNN on images. And there are two cells right here. The first one is loading the image and loading the model. And on the second one, we're going to display the information on the screen. First of all, we're going to load an image. So of course, we need the image. Let me put some image right here. So I have some images of the screwdrivers here. So I'm going to upload one of these images. So I'm going to put this one right here. And first of all, we load the image. Here is the path of the image. So we need to put the path here of the image. How do we do that? Simply we click on the three dots here on the name of the file, and then copy path. And then I'm going to paste the path right here instead of the one that I have. So content screwdrivers 3. Then the model, we need to also do the same with the name of the model. So on this line right here, test model inference config, we need to put at the end between the apices, between the quotation marks, we need to put the name, the path of the model. And we do the same. We check the model between the files, we click on the three dots, then copy path right here. Okay, I did some mistake. Copy path, and then we're going to paste the path right here. And this is to load the model. So we just, it loads the model, and it is going already to detect the results. This operation should be quite fast, probably a few seconds to load the model and detect the results. So now it's loading the model. You see loading weight from content Mask-RCNN object 006. And it took 15 seconds and the execution was done. Then we have this cell, which is showing the results on the screen. Simply, I will not have much time now to go through this, but I will just give you some idea. It's getting how many objects are detected, and then it's looping through each single object, and here getting the mask, getting the coordinates of the mask, and here we are drawing a polygon around the objects detected, and also we're drawing the mask on each object. And then we display it on the screen. Let's run this one. And this is what I have. We have the screwdrivers, and you see the mask around each screwdriver. And we have, for each of them, we have a different color to show that we are detecting separate objects. This is all regarding this demo. Of course, I couldn't go too much into details because it will take a long time. I want to make this video short and as simple as possible so that everyone can follow this. If you have a more complex scenario where there is also a different background, probably the detection will not be so accurate. So now this demo version will work mostly with a simple scenario where there is like mostly non-homogeneous background. For example, if with the same screwdriver, instead of having them on the table, you will use, for example, right here with the room behind, it wouldn't be so accurate with such training. Now, before concluding this video, I want to give you a taste of what it's on the Pro version. So if you're interested to develop this project further, you might be interested in the Pro version. So I'm going to quickly show you that, and then we can end the video. Let's now have a look at the Pro version that you can get on my website. We see Mask-RCNN Training Pro. With the Pro version, what are the advantages? The advantages are that you can train it for multiple classes instead of on just one category. You can improve the accuracy so you can have longer training and bigger images. You can import a custom detector. Also, there will be some source code, separate the source code to use this with Python and OpenCV so that you can have simple integration and extract the information. So classes, mask, bounding boxes, and score of each object detected. You can run the detector in real time or from a video, so from a video or from a webcam. There will be also the option to continue the training if it's interrupted. So with just Colab, if you close Colab, you lose the files and then you need to start everything from scratch. I integrated, so you see there is integration with Google Drive, with the Colab Pro, with the Train Mask-RCNN Pro, so that the model is saved on Google Drive. If you close Colab, you open it again, the model is still there. You can continue the training. So you can work this just a little bit every day, and it will be fine. You don't have to start everything from scratch if you want to make a really big training with some complex project. And also you can evaluate the accuracy of your model. So just let's have a quick look at the notebook. There will be some settings that you can personalize. And I want to be clear, there will be also, it's a full mini course, so you do not get only the Python notebook, but also there is a mini course where I explain each single step of what you are doing. So how to improve the training, why you need to do certain things, and so on. So for each lesson, you get a detailed blog post with explanation of everything that's inside, and then there will be on each lesson like the source code to download that you can use either on Colab, the one for the training, or also on your computer. So for example, I have on this lesson run Mask-RCNN in real time. I show how to run Mask-RCNN in real time on your computer, and then there is also the source code, and I explain this also on the video lesson that is here. And so I was showing something about the Pro right here. Also, the notebook is more advanced, so there will be the option to continue from last training, fine-tune training, so you can improve the model accuracy. Once you have the model, if it's not performing well, there is the section where I explain how to improve the accuracy, and you can evaluate the accuracy of the model. This is all for this video. I hope you enjoyed this video, and if you have any questions, feel free to post them below, and also let me know in the comments and what projects you are working on. This is all for now. See you on the next video.